we are given a sorted array and a target value. Our job is to find two numbers that add up to that target. For example, let's say 2, 7, 11, 15 numbers are there in an array and target equal to 9. Here we can see that 2 plus 7 equal to 9. So we return their indices 0, 1. Now the important thing here is that the array is already sorted, and wherever you see a sorted array and you are looking for two values, you should immediately think about two pointers. So instead of checking every possible pair, we will use one pointer from the beginning and another pointer from the end. So whenever you see a sorted array and you are looking for two values, you should immediately think about two pointers. Let's call them left and right. Left equal to 0, right equal to numbers dot length minus 1. So initially left is pointing to 2 and right is pointing to 15. Now let's add them to 2 plus 15 equal to 17. But our target is 9. Since 17 is greater than 9, we need a smaller sum. Because the array is sorted, we know that moving the right pointer to the left will give us a smaller number. So let's move right. Now we have 2 plus 11 equal to 13. Still too big. So again let's move the right pointer. Now 2 plus 7 equal to 9. Perfect. We found our target. So we return 0, 1. That's the main idea behind the two pointers approach. Now let's look at the Java code. Okay, let's first we start with the one pointer at the beginning and one at the end. Then we add those two values. If the sum is equal to the target, great, we found our answer. If the sum is smaller than the target, we need a bigger sum. So we move the left pointer forward, and if the sum is bigger than the target, we need a smaller sum. So we move the right pointer backward, and we keep doing this until we found the answer. The best part about this approach is that we only go through the array once. So the time complexity is O of n and the space complexity is O of 1. So remember this simple trick: sorted array plus pair something two pointers.